Hi, everybody. It's Mr. Hayes of Mr. Hayes' World of Math. We are in the second week of our prep course for the AP Stats exam. You can find the link to that down below. That is all free. There's the worksheets we're going to be using here today. Going to jump right in. As always, share with your friends, comment, like, subscribe, all that other good stuff, and let me know what's working for you and what's not. And if it's just everything is helpful, please do that as well. So grocery store purchases melons from two different distributors, J and K. Distributor J provides melons from an organic farm or organic farms. The distribution of the diameters of the melons from distributor J is approximately normal with mean of 133 and a standard deviation of 5 millimeters. Automatically right now, back of my head, I'm thinking Z-score. I don't know what it's about. Probably going to have to do a Z-score since we've got normal distribution, et cetera, et cetera. For a melon with a selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137? Hey, look, it's a Z-score. I know it's a shock. So the setup for it is obviously this. The one thing which apparently I forgot to write down here, which again I would suggest is saying, well, again, you're doing, data minus mean over standard deviation, et cetera, et cetera. This would be sufficient. So we come up with a Z-score of 0.8. So now is that going to be good enough for a probability? Absolutely not. Now over here, we have a question, or I've written it all out. I did the normal curve. Again, normal here with 133. I forgot this part. I'm sorry if you're a teacher and you're watching this, especially if you're a grader. But anyway, so you've got this, right? So again, the benefit of drawing this picture here is that we know that we want larger than this. So we know we have to go to the right. So either we're going to have to look up the value of 0.8 on table A, and say, the probability of Z is blank. 1 minus that is going to give us what we want. Or we can go through and we can use normal CDF as long as we label out what the parts are and do that. So normal CDF, the lower value is going to be the 0.8. The upper value is going to be a very large number, 10 to the 99th. Mean is 0. Standard deviation is 1. So we spit all of that out and we come up with this. That our probability that x is bigger than 137, which is the same as the probability of z being bigger than 0.8, is going to be 0.2119. So just about 21.2%. Yay, congratulations. You just got some points. Now for part 2, there's a couple of different ways to do it. I'm going to go ahead and show you the way that I kind of lean it and probably the easiest to kind of reason your way through, particularly if you get stuck. Again, and I'll point out the places where you can probably just kind of jump in. So distributor K provides melons from non-organic farms. Probability is 0.8413 that the melon selected at random is actually larger than that 137 millimeters that we had up above. For all melons at the grocery store, 70% of the melons are from distributor J and 30% are from distributor K. So they're asking you down here, and I'm immediately, once I see this, okay, so we now have a breakdown of melons that are big and small from each distributor, or we can figure it out. And now we have a percentage from distributors. I'm already thinking tree diagram. Now you guys obviously know it because I've already put one up over here, but that's just the way my mind works. Okay, so one of the things as you're reading this, don't get too caught up in it, but start to kind of think about, oh, they're doing this, I'm probably going to need this information if you can. So for a melon selected at random from the grocery store, what's the probability that the melon will have a diameter greater than 137 millimeters? So I made a tree chart. So here's the store. So probability of getting a melon from K, distributor K is 30, and J, why I did K on top instead of J, I don't know. Doesn't matter. It works. And so then 30% here, 70% here. So first of all, that's the whole thing. So if I pick up a melon, what's the chances that is from J or K? 30 and 70. Okay. Then from there, what's the probability if I know it's from J? What's the probability it's going to be bigger or smaller? Same thing for K. And so we break down with those probabilities. Now we want melons that are bigger than 137. So you just need to follow the branch that will give you what you want. So we want that one. And we want this one. Now remember, the tree diagram, you're going to multiply those probabilities as you go. So you will end up seeing something that looks like this, okay? So I've got 0.3 times the 0.8413. So that gives me a 25.2 for, so the chances if you pick up a melon at random that is from distributor K and is bigger than the 137 millimeters is going to be 2524. The chances that you pick up a melon is from distributor J and bigger than 137 is 0.143. Now, we don't care where it comes from. We just want to know how big it is. And so the probability that you have a melon bigger than 137 millimeters is going to be 0.4007. Just to be safe, we should probably do something like this. Probability of a melon greater than 137 equals, now let's even put the millimeters in just for fun, is 0.4007. Okay. Some of my classes were asking, well, should we do that or not? Labeling out what this is, you would, from how I read the rubric, and I would defer to people who actually have, taught this before or graded before. It looks like the 0.4007 would be fine, but again, labeling it out and being clear with what you're intending is not a bad idea. Okay. For part 7, given the melon is selected at random from the grocery store, has a diameter of 137 millimeters, what is the probability that it's from distributor J? So think about what's going on here. Okay, so you've picked the melon and you know it's big. Okay, so you already know it's from that. So like in my head, I'm thinking, okay, so I know it's from one of these groups here. Okay, so it's either going to be the 2524 or it's going to be the 1483, but it's one of those things. So what ends up happening, so what's the probability that you have it's from distributor J, given the fact that you know it's big? This part right here, and if you've seen my previous discussions from this unit, okay, let's do it in a different color. Okay, this is essentially my new population. Okay, because we don't care about everything else. We don't care about the small melons. All we're caring about is the new melons. Wow, that is awful handwriting with my mouse. But so this right here is my new population. So since that's my new population or subpopulation, that number goes on the bottom. So that's where I'm getting this. On the top, you need to then have both coming from that population and also having the characteristic that you want. So it's the probability of J and B divided by the probability of this being big. So that is where I came up with these numbers here. So, and again, since this is all one big line, the possession works, or the continuity works of saying this is what we're looking for. So my new population is what we found here, 0.4007. And then I want the ones for J and big, which is here. So that means I'm going to use this number down here. So 0.1483, divide that out, and we get a 30%, or a little bit big, almost 31% chance that if you pick a large melon, it will be from distributor J. Okay. So there's that. Let's try another one, shall we? So anyway, that's those 3 parts of the ones go there. Now, the one thing that was throwing some of my kids, just side note here, is that A, they're not writing a lot, and B, the probabilities seem easier than normal. And the probability tends to be notoriously hard. That's the part that I think is the section I think most people people who take the AP examination wide struggle with. Couple of things. Make sure if you're reading, I've said this before, answer the question that's being asked. So here they're just asking, what's the probability that the melon is bigger from distributor J? We don't have to go in and explain the thinking. We can just show our work, and that would be that's satisfying. You don't have to write out sentences for everything. The other thing is that this is fairly doable and some of these you can just kind of reason your way through without necessarily knowing exactly, just kind of relying on your wits and your gut. And I'm not saying do that, but if you don't not do a section because of that, you can probably work your way through it. And then lastly, a lot of the harder probability problems actually sometimes are in the multiple choice sections. So make sure you guys focus on that.